Right, so it's time for a little geometry, and so it's a review of a lot of properties that you would have already seen in all likelihood, but important to get all that down. So let's get going. The first one I want to show you is the parallel line property, whereby if you have two parallel lines which are indicated with these little arrows here, without those arrows, you don't have parallel property. And what's called a transversal, this line that crosses two parallel lines, that creates loads of angles in here, four here, but only two types of angle: an acute angle, and right there and there, for instance, and an obtuse angle, let's say there and there. Now, all the obtuse angles are equal to each other, and all the acute angles are equal to each other. Which is really useful property. But what we've got, they're all called different things. So these little X's here, they're called alternate angles. Right, so those there are called alternate angles. Alternate angles, and they're equal, as we just said. These ones here, using a different color, these ones here are called corresponding angles. Now they're not the only pair of corresponding angles in this diagram. There's another pair. There's another pair just here and here. There's another pair here and here. So there's lots of pairs. There's another pair of alternate angles here and here. So there's stacks of these things going on. So the alternate angles, corresponding angles, they're equal. Corresponding angles, I should write there. I'm going to have to draw another set of parallels here to demonstrate another pair of angles which are not equal, because it's one obtuse and one acute angle. They're called co-interior angles. So they're inside the parallels. Oops, they're not parallel. They're inside the parallels, same side of the transversal. They're co-interior. Co-interior angles. Now, co-interior angles are what we call supplementary, and supplementary means add up to 180. Supplementary, add up to 180 degrees. Okay, that's what supplementary means. Complementary angles, they're equal, and alternate angles, they're equal. Okay, so co-interior, alternate, corresponding. All right, let's move on. I want to show you how we can neatly prove, because everyone knows that the angles in a triangle add up to 180, but how do we prove it? Right, so here's a triangle. Let's give them the angles a name, A, B, C. Let's now produce a parallel line, a line parallel to that one there. Okay, that's great. Now what we get straight away is that we've got, oh, if they're parallel, then maybe you've seen this little, something's called a Z angle, makes a Z. That's alternate. So they're alternate, and so are those two angles there. So they must be equal. And I know that these three angles here that lie on a straight line are supplementary. So therefore A plus B plus C must equal 180, and A plus B plus C are in the triangle. So therefore triangle angles add up to 180 degrees, or are supplementary. I could have written there. Okay, that underpins a lot of the work we do. That the interior angles of a triangle add up to 180 degrees. We've talked about this word supplementary. That means add up to 180. There's another. I'm just going to a whole bunch of ideas. Complementary angles. Angles add up to 90 degrees. Now you're going to need to take all these notes down, obviously. Okay, now let's keep going with triangles. There's different types of triangles. There's what we call acute angle triangles, where all the angles are acute. An obtuse angle triangle, where one of the angles is obtuse. There's a right angle triangle, where one of the angles is a right angle. There's scalene triangles, where all three sides are different in length. There's an equilateral triangle, where all three sides are equal in length. and there's an isosceles triangle where two sides are equal in length, and therefore the two angles, base angles, are also equal in length. So what do we call this? Acute, obtuse, right, scalene, what was this one? Equilateral, and isosceles. Okay, different types of triangles. All right, let's move on to quadrilaterals. All right, little heading here, quadrilaterals. Quadrilaterals. Okay, now under quadrilaterals come three different quadrilaterals we're going to look at. Parallelograms. So we'll have a look at the parallelogram. We'll have a look at the kite, and we'll have a look at the trapezium. Okay, now the kite, his property is that he's got two pairs of equal adjacent sides. Okay, so we can write that down there. He's like this. Two pairs of equal adjacent sides. So like that and like that. That's the kite. Now the trapezium has one pair of parallel sides. So we can just make a pair of parallel sides like that and then join up the edges, and that gives us a trapezium. Now a parallelogram has two pairs of parallel sides. So it's a bit like that, where that side is parallel to that side, and that side is parallel to that side. Now coming off a parallelogram, we've got a rectangle, which is a type of parallelogram, but where the angles are 90 degrees. So it's a parallelogram with 90-degree angles. But another type of parallelogram is a rhombus. Now what's a rhombus? It's a parallelogram with all four sides equal. So it does a bit of this. What's happening with the rhombus? Because all these sides are equal, so I've got things everywhere. I should have made that bigger. So a rhombus is a type of parallelogram, just all sides are equal. And finally, good old square, which is basically a rectangle, isn't it? But all four sides are equal in length. So it's one of these. It's a rectangle, but these sides are all equal in length. Okay, there's our little quadrilateral review. Couple more things to do. Polygon angle sum of a polygon. Let's just review that. Angle sum of a polygon. Now a polygon, remember, a polygon is any sided shape. So a polygon is a triangle, is a quadrilateral, is a pentagon, is an octagon, is a nonagon, all that stuff. Any sided shape. So what's the angle sum of a polygon? Well, all right, if we've got a triangle, all right, we've got three sides. We know that's 180 degrees. That's the angle sum of a triangle. If it's a quadrilateral, we've got four sides. We know that's 360 degrees, but we can also find out, we could split it into two triangles, can't we? So 2 times 180 is 360. So if we keep thinking along those lines now, because it's going to start to get a little blurrier. If we've got five sides, 3, 4, 5, it's a pentagon. What's its angle sum? Well, we're going up by, let's see here, if we can, let's go back to what we know. We know that geometry is about what we know. Let's use properties that we know. Three triangles, 3 times 180 is 540. And in fact, every time we add a side, we 1, 2, 3, 4, 5, 6. That's a 7-sider. I've skipped off the hexagon, but now I've got 7 sides. How many triangles have I made? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 times 180. 5 times 180 is 900. 900 degrees. Okay, so how do we work this out? What's the angle sum of a polygon? Well, if we take if it's n sides, then it's going to be, what's this work? If we subtract by So if we subtract by 2 and multiply by 180, does that work? N minus 2 times 180, because we've always got 2 less than if it's a 5-sided, I've got 3 triangles. 7-sided, I've got 5 triangles. If it's a 4-sided, I've got 2 triangles. So I take 2 off my number of sides and multiply by 180. That's my angle sum of an n-sided polygon. Last thing I want to talk to you about is this concept of an exterior angle. Exterior angle. Okay, and this just saves us writing up a bunch of notes tomorrow. We can get straight on with the work. An exterior angle, let's take a triangle, for instance, and just extend one of the sides. That's an exterior angle there. That's what's called an exterior angle. It's exterior to the triangle, right? That's the little angle in there. Now, it's obviously supplementary with the one inside here, adds up to 180, but in a triangle, if we think about this, this angle here, AB, let's call them ABC, this angle here is plus C is equal to 180. So, all right, let's call it D, for instance. Let's say it's D. So we know that D plus C are supplementary, but we also know that A plus B plus C is equal to 180 from the properties of a triangle. So it looks to me like this A plus B and D should be equal, and they are. A plus B is equal to D. So the exterior angle of a triangle is equal to the sum of the interior opposite angles. So the exterior angle of a triangle, let's just make a note of that, and we'll be done for this YouTube. The exterior angle of a triangle is equal to the sum of the opposite two interior angles. So let's just make sure we understand what that is. The opposite two interior angles. So these are the opposite two interior angles. There's 3 interior angles. We're not going to, not that one, the A and the B. D equals A plus B. So for an example, if we just illustrate that one, if we've got our triangle here, and we just extend one of this side here, and we know that this is 30 and this is 40, then, and we're going to find out what C is. C will equal 30 plus 40, which is equal to 70 degrees. Okay, we're pretty good now to get on with the work requirements in class tomorrow. So I'll see you then.